When people think of the European AI Act, they usually picture standalone software, conversational chatbots, image generators, and predictive text models living in the cloud. But the regulation does not stop at the edge of the server. It dictates a precise, rigorous compliance pipeline for algorithms embedded deep inside physical machinery. Once code is wired into a piece of hardware, its legal status shifts. The rules governing it are no longer dictated by what the software computes, but by what the machine physically does. This specific regulatory pipeline carries a formal legal designation, the product path, under Article 6, Paragraph 1 of Regulation 2024-1689. For product manufacturers, a metal chassis offers no protection from European regulatory scrutiny. If your hardware houses an algorithm, you are bound by the AI Act. This places traditional hardware manufacturers in unfamiliar territory. Decades of established engineering protocols are suddenly intersected by algorithmic law. Adding a smart, adaptive feature to a traditional product, like a self-calibrating joint on a factory robot, can pull the system into the highest regulatory tier. The text catalogs the physical products subject to these rules in a master list known as Annex 1. The immediate danger is one of oversight. A manufacturer might ship a product assuming they are merely upgrading a component, entirely unaware they have legally classified their machine as a high-risk AI system. Navigating this compliance pipeline requires knowing the exact physical and legal conditions that trigger this classification. As this diagram shows, Article 6.1 operates like a strict mathematical logic gate. An AI system only falls into the high-risk category if it meets 3 cumulative conditions. The first condition focuses on the system's intended role. The AI must be intended to serve as a safety component of a product, or it must constitute the product itself. In an engineering context, a safety component is a system where failure directly impacts human health or physical safety. It is the braking algorithm, not the cabin lighting. Minor embedded software, like a digital display interface, avoids this trap because its malfunction poses no physical threat to the user. Meeting this first condition is necessary, but on its own it is not sufficient to trigger the high-risk rules. The AI Act is not concerned with every line of code inside a machine. It targets the algorithms structurally vital to keeping people safe. The second input required to pass the Article 6.1 logic gate moves from the internal component to the overall machine. The underlying product must be explicitly listed in Annex 1 of the regulation. Annex 1 draws a strict jurisdictional boundary. It specifies which existing European Union harmonization frameworks intersect with the new AI rules. If a physical product is governed by a framework omitted from this list, the embedded safety algorithm escapes this specific high-risk classification. However, this list is expansive. It covers a vast array of common industrial and consumer goods, casting an exceptionally wide net over the European market. By anchoring itself to Annex I, the AI Act utilizes existing product categories to determine exactly where algorithmic risk physically resides. The final required condition looks at the product's market entry process. The product must be subject to a third-party conformity assessment before it can be placed on the market. This means an independent notified body must legally inspect and approve the hardware. A manufacturer cannot self-certify the product and sign off on their own work. The regulatory logic is straightforward. If the underlying physical hardware poses enough inherent danger to require an external auditor, the AI controlling it inherits that same strict scrutiny. When an AI acts as a safety component inside a product listed in Annex 1, and that product requires third-party assessment, the threshold is crossed. Existing regulatory friction acts as a multiplier. The AI Act piggybacks on the strictness of legacy hardware laws to capture the highest-risk algorithms. Once that high-risk threshold is crossed, the regulatory pipeline splits into 2 distinct paths, Section A and Section B. Section A represents the direct application route, designed for general industry. This branch covers 10 specific physical categories. It includes machinery, toys, lifts, radio equipment, pressure equipment, gas appliances, personal protective equipment, cableways, ATEX devices for explosive environments, and medical devices. Direct application means the manufacturer must directly absorb the AI Act's high-risk obligations, infuse them into their existing conformity assessment pipeline. There is no intermediary safety body shielding these manufacturers from the direct text of the regulation. The requirements apply to them point blank. Traditional hardware builders, from lift engineers to toy makers, must now become experts in algorithmic compliance to keep their products on the market. The Section B pipeline takes a different approach, tailored entirely to the heavy transport industries. This section covers 4 distinct categories: motor vehicles, aviation, marine equipment, and rail systems. Applying the AI Act directly to these fields would create a legislative conflict. It would override established, highly technical safety frameworks that have governed aviation and transport for decades. To solve this, the AI Act applies only limited direct provisions to these products. The core algorithmic requirements are instead routed through existing sectoral laws. This allows transport regulators to enforce AI standards within their own native rulebooks. Section B avoids the trap of double regulation. It preserves the authority of legacy transport regulators while upgrading their rules for the algorithmic age. Building a lift or an aircraft takes years longer than writing a piece of standalone software, and the AI Act recognizes these extended development life cycles. For products caught in the Article 6.1 pipeline, the high-risk obligations take effect on a delayed timeline, to August 2027. This delayed timeline provides a critical, temporary window for manufacturers to redesign their conformity assessment procedures. The immediate mandate is clear. Manufacturers must audit their upcoming product lines against the 3 conditions of the Article 6.1 logic gate today. They must determine exactly whether their hardware routes through the direct Section A path or the integrated Section B path. Failure to map this integration correctly will result in physical products being barred from entering or remaining on the European market. In the era of the AI Act, mastering the algorithmic code is obsolete if you do not master the legal logic of the hardware it sits inside.